Today's lesson is called the distributive property. Today we'll be learning what the distributive property is and how we can use it to simplify numerical and variable expressions. Now this is the algebraic expression of the distributive property. I'm with this in your notes. So the distributive property. Basically we are distributing or we're sharing our A with everything that's inside our parentheses. In this case it's our B and our C. Now remember, since there's parentheses, that means we are multiplying. So when we're multiplying, we end up with A times B, which we get right here. I have a plus, so plus, then multiplying A times C, which I get right here. So that is the distributive property. All we're doing is basically we're sharing. Now the distributive property also works even when we have a subtraction sign or a minus sign or a negative sign. So once again, we are sharing. So I have my A times my B, that's where this comes from. Then I have my subtraction sign, which is also right here. Then, once again, I'm sharing my A with my C, and that's where I get my A times C is. So it works for positives and for negatives, or when we're adding or we're subtracting. Still, we are sharing. So for example, we're going to use this example. 3 times the parentheses 4 plus 5 and parentheses. Now I'm going to show you two ways of solving this. Now, the first way you're used to is the order of operations. So don't forget your order of operations. Remember, it's PEMDAS. So what do we need to do first? We have to do what's inside the parentheses first. So what's inside the parentheses? My 4 plus 5. So 4 plus 5 is 9. Then, what's our next step? It's to multiply. What's 3 times 9? It gives you 27. Now, I'm going to show you the second way. We can also use the distributive property. So how are we going to do this? Well, if you notice, our model of A times the parentheses B plus C is the exact same thing as 3 times the parentheses of 4 plus 5. So what are we going to do? We're going to be sharing our 3 with the 4 as well as the 3 with the 5. So I've distributed my 3, I've shared my 3 with my 4 and my 5, still following PEMDAS, so still going. Now what are we going to do? PEMDAS tells us we have to multiply first. So I multiply, 3 times 4 is 12, 3 times 5 is 15, and then I add them together, and I get 27. If you notice, they're the same exact answer. So I know that the distributive property works. How do I know it works? Because I end up getting the same exact answer. Now you might be asking yourself, well, why do I need to do the distributive property? Seems like extra work. So why do we use this? And I'd like this in your notes. Why do we use this? You're about to find out why. Because we're going to be getting some variables thrown in there. Now we can no longer use the order of operations. Whoops, one second. Now why can't we use the order of operations? Well, if you noticed, we have a variable. What's x plus 2? Well, I don't know because I haven't told you what x is. But we still want to solve this. So how we can solve this now? Using the distributive property instead. So since I'm with the distributive property, no, I can share my 3 with my x and my 3 with my 2, and I simplify as much as I can. What's 3 times x? Well, 3x. What's 3 times 2? 6. So this is going to be my answer. So this is why we use the distributive property sometimes. So I need you to write down the directions as well as example number 1. We're going to do it together. So we're told that we need to use the distributive property. So I share my 5 with my x, which is going to give me 5 times x plus, now I have to share my 5 with my 3. I'm distributing it, so 5 times 3. Then I'm going to simplify. So I end up with 5 times x is just 5x plus, what's 5 times 3? 15. So that will be my answer. Now on your own, go and try number 2. What do you think the answer is going to be? So once again, we're using the distributive property. So I have to share my 4 with my 3, which is 4 times 3. Then I have a minus sign right here. So bring down my minus sign. I have to share my 4 with my y, so 4 times y. And now I simplify. So what's 3 times 4? It's 12. Bring down my subtraction sign. 4 times y is 4y. Now, I like to have my variable out in front. So I'm going to go and rewrite my answer. So if you have this as an answer, it's okay. But I like to see it a little prettier. It'd be negative 4y plus 12. We like to have our variables out in front. So either answer is okay, but I prefer this answer. Now I'm going to show you something called the area model for the distributive property. Now, why are we calling it the area model? Well, why? Because you've been taught. How do you find the area of a square? You always do length times width. So we're going to use that same idea to figure out the distributive property. Now before, I was telling you, okay, 4, so 5 plus 2, so I share my 4 and my 5, so 4 times 5, share my 4 and my 2, 4 times 2, end up with 20 plus 8, so 28 is my answer. Now if you find this a little confusing, try using the area model instead. So this is how it works. I have my 5, which I put right over here, and I have my 2, which I put right over here. So watch and see. Remember, I told you area is that length times width. So what is 4 times 5? 4 times 5 is 20. Then what is 4 times 2? 4 times 2 is 8. Now why am I multiplying my 4 and my 2? Well, because this side is also 4, so I'm just multiplying these two values to get what's inside. So, what's the area of my entire rectangle? Well, let's combine them. So I end up with 20 plus 8. What does it give me? 28. So it works. Both answers will work. So if you'd like to use the distributive method this way or the area model, it's up to you. Because either way, you're going to get the same exact answer. Now, going right down the directions, we're going to be using the area model to simplify, and go and write down also example number 1. Sorry for the technical difficulties there. So make sure you have the directions and example number 1. So I'll be showing you how we're going to be using the area model. So since my 3 is out in front, my 3 goes over here. My x is right here, so it goes right next to it. Now, since this is a plus 7, that means I should also have a plus 7 over here. So let's use this area model. So, what is 3 times x? Well, 3 times x is just 3x. Then what's 3 times a positive 7? Well, 3 times a positive 7 is a positive 21. Can I combine these together anymore? No, I cannot. Since I can't combine them any further, my answer is just going to be 3x plus 21. Now on your own, go and try to solve number 2, not number 6, number 2. So I have a negative 2 out in front, so my negative 2 goes out in front. 2a goes right below. So I have my 2a, a, then I have a positive m, so I do plus m. So now I multiply. So what's negative 2 times 2a? Well, negative 2 times 2a is negative 4a. Then what's negative 2 times a positive m? Ends up being a negative 2m. Now, can I combine these together any further? No, I cannot. So my answer ends up being negative 4a minus 2m. So I'm going to write me a 2-sentence summary. What we learned today, we learned about the distributive property as well as the area model to solve simple expressions and variable expressions.